Hey, I'm Thomas Serbuchen, also known as Dr. Z.
And I'm Ellen Stofan, also known as Dr. E.
And this is the next episode of Easy Science.
We're here at the Stephen F. Udvar Hazy Center, our other Air and Space Museum. Today we're going to be talking about something a little different that some people might not associate with NASA.
That's right, we're talking about balloons. Balloons that float very, very high up there in the atmosphere.
Now this was actually a really special balloon called the Breitling Orbiter 3. It took Bertrand Piccard and Brian Jones around the world non-stop for the first time in 1999. So a record-breaking flight that we celebrate here at the Hazy Center. But you have a little bit of a connection because obviously, Thomas, you're from Switzerland and this launched from Switzerland.
Exactly right. I remember, of course, watching this. There was tremendous coverage in all of Switzerland, also all over the world.
Well, to me, what we celebrate here at Hazy and at the Air and Space Museum is this idea that innovators and explorers help to change the world. And balloon science really helps us understand not just our world better, but actually the whole universe.
That's exactly right. The essential idea of a balloon is to move an experiment over the atmosphere. Per square inch, there's something like 15 pounds of atmospheric weights on top of us.
Sometimes we have to make our spacecraft really small if we're trying to get them all the way up into orbit. But going up in a balloon, we can actually take a fair amount of weight. That's important because the more mass you have, that means the more instruments, the more science you can do.
Exactly right. So we can bring up to 8,000 pounds.
How big are these balloons and how long do they actually stay up?
We have a variety of balloons. The biggest ones are so big they fill a whole football stadium. Some of them last for hours and days, and the longest ones, the super pressure balloons, last for up to 100 days.
And one of the things I think it's important for people to understand is they actually rely on balloons every day in a way that they might not know about. Weather balloons launched every day help us to understand and predict tomorrow's weather.
NASA launches about 15 balloons a year from a variety of locations all the way from New Zealand to Texas.
We actually have 3 different NASA instruments that flew on balloons in our downtown museum. All of them were looking at radiation left over from the Big Bang to help us understand the Big Bang better.
These measurements have really transformed our understanding.
Now it's hard for people to understand how we can be studying the Big Bang from our atmosphere, something that happened billions and billions and billions of years ago. But all those particles are coming from a huge distance. It takes them a long time to travel to us. So it's really almost an echo of the Big Bang that just took a long time to reach the Earth. And that helps us to actually understand that event that we don't understand very well yet.
So as we make those measurements and combine them with measurements from the ground, but also from spacecraft, that picture of the earliest moments of the Big Bang, and then also the evolution of the first galaxies, the evolution of matter is really coming together. We've made a lot of progress, and in part because of these balloons.
Now we also study the Earth from balloon-based instruments. Like I know one of the experiments that was done not that long ago was actually looking at how much solar radiation comes back from the Earth into space, which is important for us trying to understand how does Earth's climate and weather work. And that solar radiation and how much stays in, how much leaves is really critical to understanding that.
That's right. What's really important about that experiment too is that we use the balloon really as a platform to try the technology. We can, for probably 1% of the cost, go try it out and make sure we understand it before we're finally ready and putting it up there in space. The other thing that we don't often talk about, and I'm really passionate about, is it's with these very balloons, we actually train the next generation of explorers and the next generation of instrument makers.
We actually run a summer camp here at the National Air and Space Museum for girls on aviation. And one of the things that we have the girls do is actually launch a weather balloon, basically, up to the stratosphere. Seeing the looks on their faces when the data comes back and realizing that they're part of this experiment. You go try, you put something up there is really exciting.
So Ellen, I have a question for you. How long do you think it would take until we have a balloon in the atmosphere of Venus?
Venus is a perfect planet to explore with a balloon because while it's very hot on the surface, it actually gets cooler as you go higher in the atmosphere. So you can't really have a rover on Venus, that mobility where we want to visit lots of different sites. It's just too hot with a rover. So the idea is, could we send a balloon to Venus that could go up into the atmosphere, cool off, move along, come back and explore a different site.
Perhaps one of your innovators will figure out how we get to Venus with a balloon.
Absolutely, that's our role here at the Air and Space Museum, is to inspire that next generation of innovators and explorers. If you have topics for us or questions, please send them in and we'll talk about them on a future episode of Easy Science.